Look at us, standard form, day 2. If you recall, standard form is the x by the c. It's where we have the x and the y on the same side of the equal sign. And we usually graph these by finding the x and y intercepts. Today we're going to turn some story problems into standard form equations. So let's see what we've got. You are sent to the store to buy sliced meat for a party. You're told to get roast beef and turkey, and you are given $30. Roast beef is $4.29 a pound, and turkey is $3.99 a pound. Look, I bet we're going to need these numbers. We have $30. Beef's $4.29, turkey's $3.99. Write an equation in standard form to relate the pounds of each kind of meat you could buy at the store with $30. How much money do you have to spend? $30. Sick, dude. What is the cost per pound of roast beef? Well, it says roast beef is $4.29. And for turkey, it is $3.99. What are you asked to do? We're supposed to find out how much of each we can purchase. With $30, I guess. All right. Let's see what else we got. What will the variable x and y represent in this situation? Now, you could assign either one to either of the things. But let's say we're going to call, since roast beef was the first thing they told us, we'll say roast beef is x. And then we'll call turkey y. Write an expression for how much money is spent on roast beef. Well, roast beef, it says, is $4.29 per pound. If I was to buy 2 pounds of it, you would do $4.29 times 2. Now, we made up the 2, but that's the number of pounds we want. Now, we're calling roast beef x. So we're just going to multiply x by however much it costs. And it costs $4.29. So we're going to say 429x. Keeping that pattern going for the turkey, which is y, we're going to say 399y. Write an expression for how much money is spent altogether. So here's how much we're spending on roast beef, 4.29x. Here's how much we're spending on turkey, 3.99y. If we want to know the total amount, we would add those two values together. Write an equation which says the total amount spent equals the amount that you have to spend. So it's going to be this same setup, 429x plus 399y equals the total amount of money we have, $30. Not too bad, right? Suppose you bought all beef and no turkey. How much beef would you bring back to the party? Does this seem like a reasonable real-world response? I already forgot how much the beef was. I think that was the 429. Yeah, beef's 429. So we could say 429x equals $30. Let me grab my calculator, because that's $4.29 times x. So if we're trying to cancel that out, we're going to divide by $4.29. Divided by 429, divided by 429. And it comes out to 6.993 pounds. And it goes beyond the 3. Now, you might be like, we could just round that up to 7 pounds. But if we said 7 pounds, 429 times 7 is $30.03. Store's not going to let you have 7 pounds because you only have $30, unless they have one of those like, hey, take a penny, leave a penny. You might be able to, but that's not in there. So we would say 6.993 pounds. Or if they said like, you have to get whole pounds. Again, we can't get 7, so you would bump it down to 6. But that kind of depends on the question they're asking. Does this seem like a reasonable real-world amount? Sure. Yeah, all right, seems reasonable. 7 pounds of beef. If you want to go shopping and buy jeans, oh, this is a try on your own problem. Sweet, so I'll read it, then pause it, give it a whirl. If you could go shopping and want to buy jeans at $40 each and shirts for $20 each, how many of each could you buy if you have $100? So try to set up an equation and then try to solve it using intercepts and see how much of each you can buy. Go ahead and pause it. All right, so I'm calling jeans, we'll call X. And I'm going to call shirts Y. So each pair of jeans is $40, so we could say 40X, plus the shirts are 20 each, and we have $100 to spend, right? So there would be the full equation. Now if you want to figure out how many jeans you could buy, you could just set up 40X equals 100. If you want to know how many shirts you could buy, if you were just buying shirts, that would be 20Y equals 100. So here we can divide by 40, and we're going to get 2.5. Are you going to buy 2.5 pairs of jeans? No. So you could buy 2 pairs of jeans. Because that would get you up to $80. So if you're just buying jeans, 2 pairs. The shirts are 20 each, so if you divide by 20, you get 5, right on the money. So you could get 5 shirts. Now, if you were to graph these, standard form graph, let's say jeans is our X value. And we can get, well, let's do shirts this way. Shirts. So shirts we can get up to 5. 1, 2, 3, 4, 5. Jeans we could technically get up to, the y-intercept would be 2.5. So if we graph this, jeans would be 2.5. The shirts would be 5. If you were to connect this with a line, like we were graphing in standard form, any combination on the line or under the line is what you could afford with your $100. So you could get 1 pair of jeans and 2 shirts if you want. That falls in there. You can get 1 pair of jeans and 3 shirts. That would actually be right on the line. My line was just imperfect. But that's a cool thing about these application problems. If you were to graph it, it shows you all the combinations. That might be the last slide. Fun. We're done.